Okay, so here's worked example 2.25, page 73. I think it's actually pretty self-explanatory in the book, so I'm not going to really work through it, but it doesn't have numbers in the book, so I'm going to throw one out here for you here and see if you can do it with numbers, and then we can practice. So let's say this larger mass has a mass of 5 kilograms. The smaller one, which is hanging over a pulley, has a mass of 2 kilograms. Let's say the surface is frictionless. Go ahead and calculate the acceleration of the masses as well as the tension in the string. I'd say hit pause, try it out, and then we'll walk through it. The book shows two methods on how to do this. I'm a little bit more, for me the second method makes more sense. The first method works, but it's a little bit more complicated. I like the second method, so that's the one that I'll choose to use. So with the second method, you take the whole system combined, because notice the tension in the string. There's the tension acting on the 5 kilogram mass and the tension acting on the 2 kilogram mass. And essentially, if you look at the system as a whole, that tension is an internal force, which doesn't affect the whole thing. So I like to go with looking at the whole system and basically net force equals ma. The net force in this case is just the weight of the second mass, 19.6. And here's just where you have to be paying attention. The mass is actually the sum of the two masses. So that's going to be 7 kilograms times acceleration. So then you can solve for acceleration and see what you get. So you end up with 2.8 meters per second squared. Now go ahead and use the method that we used previously in one of the earlier example problems to figure out what the tension in the string will be. So to find the tension in the string, you look at one of the masses individually, and I'll usually choose to look at the mass that only has one force acting on it. In this case, it's the 5 kilogram mass. Again, I'm going to go F equals ma, and the force that's acting on the 5 kilogram mass is the tension. There's no other forces here. The mass is 5. I know the acceleration is 2.8. And therefore the tension in the string should be 5. So you end up with the tension being 14 newtons. And now to double check, see if that works out for the second mass, for the 2 kilogram mass. Now you have a 19.6 newton force downward, a 14 newton force upward. So see if you can plug that in to F equals ma and get the same acceleration. That's always a good way to double check. All right.